Response video of sorts on the subject of the two-slit experiment. I actually have planned, I have notes, a whole page of them, doing a video on photon interference. And, you know, even I had the sign even made. The sign, photon interference. It's backwards. For whatever reason. Anyway. But this video came up, so I'm going to do this response video. So some of this is going to be redundant, unfortunately, but whatever. It's the way it has to be. But it's just so bad. It's such a perfect example of how wrong and backwards and fake and phony physics is. I mean, if this is what they are taught in universities, they don't even have the slightest clue what they're talking about. They're just reciting what the minister has told them. They haven't, you know, they haven't walked out into the real world, so to speak, to have any context, knowledge, real familiarity. Just some gross generalization, and they say that's good enough evidence for me. I don't need to know the real facts.
Hi everyone, today I'm at the University of Sydney. Some familiar faces, some new. We've got Peter,
obviously a shitty university,
Liam and Raina. And today we're going to take a look at a couple of experiments. These are both versions of the double-slit experiment, and they're going to be at two vastly different price points. So we're just going to compare them and you know, see if it's worth it to put in the big bucks for this experiment.
Yeah, it's really, it's an insanely simple experiment, right? So, I mean, two holes, an light source, and a target. And so, yes, you can do it more carefully and less carefully. And so what? Insanely unimportant. The real thing to understand is that this pattern is created by other things, including a single slit, and including just any old surface. And, you know, that's what they don't understand, is this is a surface phenomenon. It has nothing really to do with slits. But anyway, let's continue. I mean, you just can't see it on a regular surface because too much light bleeds it out. So unless you do it with lenses and carefully, you can't see it, but it's there.
Experiment. Now, the double-slit experiment really looks at the wave-like nature of light.
No, it has nothing to do with it, really. I mean, Newton did the experiments 150 years earlier than Young. Okay, Newton's rings are essentially one form of them created by this small aperture, and the single slit is just making the single aperture a rectangle instead of a circle. So you're just taking the pattern going one way off straight surfaces instead of round surfaces, but that's the only difference. And Young's experiment was completely unremarkable in that context, and Newton had also done it with a single hair, showing that it's really a surface phenomenon. But just keep pretending the truth is this mush.
Because we are setting up an interference pattern by passing light through two narrow...
Says you, based on no evidence, really. Just nothing. You have no evidence that this is interference. You have an on-off pattern. You have a pattern that doesn't even match your math in the sense that it's not sinusoidal. It's not a gradual on, gradual off like it's supposed to be. So you're just pretending, you know, because it has a vague resemblance to. It vaguely resembles in one circumstance. So yes, it has a vague resemblance. Water waves certainly don't have bands at the same, you know, closeness as photons, of course. But they're obviously not the same thing. The water's going up and down in one place and it's quiet in another place. This idea of photon plus photon equals no photon is nonsense. The photons are being moved. They're not being destroyed. They're going somewhere. They land somewhere. They land in a different location. They're being diffracted.
And plus to give us slits. So let's see what we can make. First of all, on the chip, we've got some blades and we've got a little laser pointer. So the first objective is to get two narrow slits in the piece of aluminium foil. If we have here on the camera, we have a few failed attempts at the double slit. So trying to get two two really close together was not actually as easy as it might sound. These are nowhere near close enough to set up the interference pattern.
Right, so apparently they don't even show what measurements they actually come up with for any of this stuff. Obviously it's very important how wide the middle impediment is. It changes the pattern tremendously. You can only get the really good double slit pattern if you have a very small slits very close together. So just more, let's not pay attention to the science.
Little do you know, if you use a ruler, I think it becomes easier.
Now we want to move it just far enough that the aluminium is not going to tear itself apart.
So the simple solution is to take a very small wire or some other very small thing and put it between, you know, cutouts in a piece of paper, and then just move two razor blades in next to it, you know, and much better. I mean, if they took the edges they're making and looked at them under a microscope, they're not going to be very good edges.
Alright, cool.
So they have to be very close together, otherwise it just acts like a single slit.
So what a single slit diffraction pattern looks like.
Doesn't act like a single slit, so just more garbage. If the slits are far enough apart, yes, they're two individual single slits.
Like as if we just passed the laser, you know, through a single slit. We'd get something that was sort of high intensity in the middle and goes out to sort of lower intensity or fainter towards the edges.
Okay, so that's the magic moment where the more the canard, okay, that somehow the single slit doesn't make a fancy pattern. That doesn't have lots of little bars in it, just like the double slit. When it has exactly the same number of bars, you just make the slit the right width. That's it. So in one math they use the width of the slit, the single slit, and in the double slit math they use, oh, it's the width of the slits that is the distance. So, you know, but this is the canard. You take the same slit that's used in the double slit, just use one slit, and you'll get all the little bars just like you do in the double slit.
For a single slit, we also see a pattern of light and dark regions.
So just more garbage, light and dark regions, and more this cliche fixing of the evidence. Let's distort the actual truth. Okay, if you did the same thing to the double slit, that is, you made the openings of the slit really, really small, you'd end up doing the same thing to the double slit experiment and just turn it into blobs.
Here is a comparison pic from
I mean, it's just a fact. You just make the single slit, that single slit pattern was created by making the slit very, very narrow. You just make it a little bit wider and you get lots of bars.
Since
Fact.
the slit is wider than the wavelength of light, we treat the wave at the slit as a large number of point sources, and we get
So we treat it as a large number of point sources. Now, the Huygens says an infinite number of point sources, which is, should to any physicist sound a little bit stupid. But that's what Huygens says. So you should at least see. There's no recital of the truth here. A large number, we'll just vaguely say, you know, any number we choose. Yeah.
interference because of differences in path lengths from each contributing ray.
Yes, completely engineered, and it would always be true of anything going out at a distance, you know, spreading, in the sense that the pattern is displayed and it is angularly different. But there's all there, you can just say that it's all the same angle. You just add 3 plus 3 is 6 plus 3 is 9 plus 3 is 12, and you just change the angle by the same number. It's an on-off pattern. On, off, on, off, on, off. The simplest pattern you can create in the universe. And yet you have some special knowledge that tells you, I know that on-off pattern isn't just an on-off pattern. Somehow it's interfering. It's an interference pattern.
Peter will briefly explain wave interference.
Basically, a peak and a peak coming together in a wave creates a larger peak, right? Or you can get a peak, a trough, right, when it's a little out of phase.
Right, so again, this is all premised on somehow these waves of wave of single photon. Somehow a single photon is a big, long, huge, long, wavy thing. Okay, and you know, in the original double slit experiment, it was deliberately bowed, so the light didn't come in as plain waves; it came in as bowed waves, you know, as peaked waves. So this is just all of the history they don't pay any attention to. The truth they ignore. And you know, and then there's this notion that somehow these waves, these little photons, can't somehow get through this gigantic slit compared to them, and you know, the waves have to break into a million little waves and go in all kinds of directions, the waves, and then somehow they all collapse to the one point that the photon actually goes. By some magic, all that energy is reabsorbed and lands in a location by some magical way of the waviness. It's just such a rubbish theory. It's got spooky medium, spooky waving, spooky all over the place. There's just nothing reasonable in this phony explanation.
And they cancel out to form nothing, form zero. Right? And you get that in acoustic waves. Right? So
Yes, which are tension. So yes, in acoustic waves there's tension. There's two things moving in different directions and they absorb each other's energy and neutralize it. That makes sense. Okay, photons neutralizing each other, that doesn't make any sense.
when you have a guitar and the frequency is very close, right, and it starts beating, so it starts creating these peaks and troughs, and they start combining in kind of interesting ways. But you can also get that with light, with the single slit.
Yeah, well, if you do a single slit with your sound or with your water waves, you're not going to get any big pattern. You're not going to get a whole bunch of little bars. You're not going to get any of that crap. So unless you make the slit much smaller than the wavelength of the waves you're putting through the slit, you're not going to get anything at all but a nice little round wave. I think he's going to draw that, which is hilarious.
So while you're there, we're trying to achieve something called the double slit. So how's that going to be different? Why would there be something different on the board?
So with single slit, we pass it through a slit. You have to make do with my drawing, okay? You can imagine, say, waves coming up. They come...
A creative drawing. But anyway.
Yeah, we're going to call them waves like this. Okay?
Right, and the Young didn't do it with waves like that. He did it with sunlight, and he put the sunlight first through a small aperture and essentially bowed it and spread it. So let's not pretend. Let's just pretend we flat waves or somehow have something to do with this when it has nothing to do with it.
Wave fronts move along, and when they hit this, they're going to come out. Instead of coming through flat, they come out as waves.
Yeah, it's kind of circular.
Whether they were circular going in or circular going out, that's right, water waves will do that because there's a thing called friction and tension in the water. So there's friction along the side, so it drags. It drags the tension of the water, and that's what bows the wave. What's your explanation in light, photons? What do you think do you think the photon wave is dragging? And again, Huygens says it's an infinite number of little wavelets, so you're not even drawing it correctly. You're supposed to say there's an infinite number of little waves coming off the thing. Somehow that bows it? That doesn't even explain bowing it. Huygens didn't think of waves as coming in as flat waves. He thought of waves coming in as round waves, bowed waves.
You drew a line through.
Yeah, that's good.
So that's our wall.
Yeah, that's
This is our wall, this is our single slit, and this is the the ray of light coming from the
Yep.
laser.
And we
Right, and there's absolutely no interference there. Okay, so just understand, this is it draws a line through it, like pretending this is on and this is off and this is on and this is off. That doesn't happen in reality. Every one of those waves goes across the surface and makes light across the whole surface. There's no pattern. It's just absolute nonsense. It's not even true to the way physics is taught. Huygens makes two waves that interfere with each other to make a pattern with a single slit. So they're not even explaining the bad answer right. They're doing bad physics badly.
get like a bright spot here.
Yeah, peaks and troughs.
Yeah, you don't get any peaks and troughs. No, that's all a big fat lie. You're full of crap. Nothing's going to happen with sound or water. That's nonsense. Sorry, nonsense.
Along there.
A bit like it.
Right, so they just draws it on top of there like, sure, why not? I can just draw this crap right on top of there, and that's what it does, because I say so. Because that's what my teacher taught me. Nonsense, rubbish, garbage, crap. This is bad. This is just bad physics. Bad, bad, bad. It's horribly inaccurate.
Then you can draw out your double slit. I'm running out of board space here, bear with me.
You have plenty of boards there to deal with.
And so a double slit is a double slit. I know, it's how many years of university?
Too many.
Too many, I don't disagree. Waves come along again, but this time they go through the slits again.
You'd think the guy would have practiced doing this, you know, drawing the waves the right way or something. I mean, it's just so bad.
And you get an interesting drawing. So you basically get 2 times yellow. And they start 2 easy like that. Another one more to a and so, something got too well on the board, I can't remember.
Yeah, and so you didn't illustrate anything because you did it so badly, but where the little X's are supposed to be where the dead spots are. Jesus.
But this then leads to a broken piece of chalk.
But you actually described this in another video.
Yeah, I do have a video about this.
Yeah, wrong again. So this is just such bad physics. It's so freaking bad. It just demonstrates that this is why physics is so broken. This is how they're educated. They think this is being intelligent.
And leading on to using single particles to do this, but we're just using light at the moment. And so like what Peter was saying,
single particles to do this. So again, just more like photons aren't. And like, yes, in all those other experiments, like for example, they're all different. The patterns are very different. Like in electrons, it is a very smooth pattern. And why would that be? Well, you might think about the fact that when electrons interact with electrons, they don't hit each other. They bounce off each other's repulsive magnetic force, their charge. So that's going to cause the idea of having a variant in your angle, and that's going to make the pattern much smoother. But yeah, don't think too much, right? Don't think about what you're talking about. Just recite the Bible.
Before, like peaks and troughs
Badly. Misquote your own Bible.
can either cancel each other out or reinforce each other to get bright spots and dark spots.
And again, that doesn't what happens in water. So water goes way up or way down, and this goes flat. Way up, way down, flat. Photons aren't doing that.
That are now on the wall that are a result of, you know, 2 different diffraction patterns.
It shows that the light acts like waves.
No, it doesn't show that. So that's your interpretation. And it's, in my opinion, insanely weak interpretation, because photons don't act like waves. They act like a little tiny corpuscle, and every time they're actually measured, they're always a little tiny corpuscle in one location. And every time we see them in the real world, they're always moving in dead straight lines and in such order that we can see stuff a billion or 10 billion light years away. We can see it in its right form, because those photons didn't interfere with each other, didn't screw around, didn't fuck up in some way. They managed to go 10 billion light years, all staying exactly the right distance from each other and going in dead straight lines. That's what photons do. They don't spread out and go all over the universe and do all kinds of wacky crap.
It was actually a really fundamental experiment in the history of...
Right, it wasn't a fundamental experiment. It was a stupid, redundant experiment. I mean, it was an experiment Newton had already done. It's incredibly unremarkable, the fact that you create rings of light, okay, when you have a small aperture, when you have surfaces that are close together, because then a high percentage of the light is traveling near the surface. And apparently, logically, one might deduce that, well, maybe the surface has something to do with the experimental results. Maybe this isn't about what photons do. Maybe this is about what the transition between one medium and another medium, and how that transition is a complex beast. Duh.
Science, for that matter. Yeah.
For sure. And it's really cool that we can do it so relatively simply.
Well, let's try and continue with that simple experiment. Okay, where's the foil?
That's cool. Awesome. They're pretty.
So this is just so bad. So the slits are tiny, the middle impediment is humongous.
Close together.
Well done. Hopefully they're close enough.
Well done.
We get a good pattern.
And so we're just taking a cheap laser, just firing that onto the board. So that's still a single slit.
Oh yeah, that was good. That was good. I can see it there. Yeah, there. Cameras. So yeah, I can see like a lot of bands of dark and light in there.
Yes, which is exactly what the single slit would do. And there isn't any evidence that it's doing the traditional double slit thing of creating the sidebars, the very dull and then light again, then dull, then light. So, in a sense, yes, they're doing the single slit.
It's distinctly different from the single slit.
Wow, yeah, we see that.
So, distinctly different from the single slit pattern when it's not distinctly different from the single slit pattern. That's exactly what a single slit would do. If they made a single slit, they would see it do that. So they just have this idiotic notion because they've been propagandized to. They've been the evidence has been shown to them in only one form to validate the argument, and they actually don't know that a single slit creates dozens of bars of light. Just make it a little bit wider. They don't know that. A fundamental fact, and they don't know it. A fact Newton knew. They don't know it. A 350-year-old fact, and they don't know it. 300 and whatever years.
It's cool.
I might be able to block one of the slits as well.
The camera's definitely.
I was looking at my finger. It's good.
But yeah, that is a pretty good interference pattern for a piece of foil and a laser pointer.
To me, it just looks like speckles.
To us, it looks great.
It looks very cool.
So again, they don't even know what they're supposed to be looking for, which is the pattern that breaks. Not just bars, but breaks. And the double slit traditionally only has 10 or 12 bars in the center portion, and then 7 or 8 in the second thing, and then diminishes as you go further down. But the sections that are bright, never have 50 bars in them. It's always 12 or 16 or some other number like that.
It's very nice. I'm not sure
How expensive is the laser pointer?
You could probably buy this for like $2 on eBay. I suppose you'd have to buy a whole roll of this, right? So.
Okay.
Well, no, maybe you can just get it with alfoil from.
So what is the...
So this nonsense is just such a waste of time. I should probably just jump through it. They're just going to talk about how much foil costs. So, I mean, it's kind of a waste of time. Just gibberish.
Setup.
Expensive setup we could
What do
find.
we have here? We have a much more expensive laser. Who knows the price point of this laser here?
That is a 20 milliwatt helium neon laser, which will set you back something close to $2,000 for the laser and the power supply.
Okay.
Yeah, it's a very nice laser.
Yeah, so we have this, which is a series of...
So again, the laser has so little to do with it. Just about nothing. It's all about the quality of the aperture you're putting the light through. It's essentially a lens.
precisely made double slits. Probably more accurate than ours, but yeah, we pay for. Really just two...
So this doesn't make much sense, because if these slits are on film and they're using this laser, it should be melting this film. But it is a red laser, so it's not so big a deal a laser anyway, if it's not just melting that crap, because from my own personal experience, a green laser will just melt the hell out of the film.
Components that we're working with?
Yeah.
Yeah.
Okay.
So this is about $2,000. This is about buying a good set of double slits will be about $200.
Cool.
So provided they're very good. Oh, we didn't count the wall.
We didn't count the wall.
You can do it on a wall, so it doesn't.
You could substitute this for an actual wall, which could be the most expensive item of all.
Yeah, buying a wall's quite hard.
Yeah.
Especially in Sydney. Yeah. Anyway.
But there's a common factor between both of them, so that's okay.
Yeah, that's true.
Do we need to provide a safety warning for this laser? Is this a...
This is
do not
not...
hold it at home?
This wouldn't be an eye-safe laser. I mean, it's not going to blind you instantaneously.
But it will blind you.
But
We
yeah,
shouldn't put our heads down at the same level as it.
definitely not. And reflections can be an issue as well. as you can see, because we've got it lined up pretty much perfectly, the reflection is coming straight back to the laser, which is good for us.
Thankfully, the restriction on laser pointers is only for handheld ones, so we can get nice strong ones as long as they have key and power supply.
And so there is now a professional double slit.
See how these cameras pick it up.
With 2 slits very close.
I'm actually just going to turn off the lights.
They even have to do this in a, you know, just waste more time. Like, could you just waste more of my life?
Just so we can get a beautiful cinematic montage of this.
This is just such gimmick. So this doesn't even illustrate anything because obviously they didn't use 2 slits that are that far apart, so we can't see where the real slits are here at all. So thank you very much. What's this for? This la 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 la.
God, that looks amazing.
Yeah, but like this is obviously much more.
Wow.
So they did this even poorly. I mean, okay, it has a little bit of the double slit, a hint of it, because you got the bars get weaker here and they get light, but it's really a poor pattern. That's why there's so many bars in the middle.
Stark. You can really see the interference pattern in the bands.
What's with all of these? The ones above and below?
Guess what? The slit has a top and a bottom, even though you don't pay much attention to it. Yeah, it does. And those are the bars of the light going up and down from the slit.
That is more than likely just oil or scratches on the surface.
I had cleaned it before, but it looks like it's come back.
With a vengeance.
Quite an important experiment in physics because we're really looking at right here the wave-like properties of light.
Now, you're looking at really strong little bars of light, okay? So again, it doesn't have any of this wave property thing. It certainly isn't doing its sinusoidal obligation of going light and dark gradually. Certainly the diminishment of from bar 1 to 2 to 3 to 4 to 5, all these maxima are supposed to be reducing at a much higher rate than they are in this actual image. The math would say they're supposed to.
Which is something that, you know, when they were discovered, sort of blew people's minds. And so we can check.
So again, Newton's rings didn't blow anybody's mind, but Young shows up and does the same experiment essentially, and it blows everybody's mind because he uses rectangles. And he didn't even do that right. He used 2 pinholes and created little round dots. And he didn't use monochromatic light, so they all sort of blended into each other. Different colors.
I do appreciate.
Still blows people's minds.
Yeah, it's
Still totally blows my mind right now.
So, just again, weak evidence. I mean, this is what they draw conclusions based on. So there could be lots of reasons why sending light through close to surfaces causes this pattern. And clearly, if you engineer the experiment in certain ways where you block some of the light, then you'll be able to see the pattern.
Yeah, we can appreciate what we're actually looking at if you know some of the theory behind it. We have
Some of the theory. You know some of the theory, but you don't know enough of the facts. You don't know that a single slit produces the same bars. Exactly.
neon laser. I believe that this was chosen not only because it sets up a wonderful double slit on the wall here, but also because it was nice and expensive.
So again, it wasn't a very good pattern. The slit width was too wide and the impediment width was too small.
And we wanted to really taste the top level of experimentation here. So, is this the most expensive laser we could have used? Could anything else do this job?
That we own?
That we own. This is the most
Definitely,
yes. It has a very narrow peak, so you get a very nice pattern.
We own. You mean the school owns?
Diode lasers can be just as expensive, but they're peaking as narrow, so you'll get a little bit more of a smudgy kind of pattern.
The laser pointers are diodes.
I think the thing that's interesting to me about all of this is that, like, I know we're kind of doing this like cheap and expensive experiment as like a bit of
Yes, the whole video is cheap, tacky, inaccurate, bad physics, a joke on intelligence, a piece of fluff basically being made for commercial purposes.
A joke and a bit of a gimmick, but what I really love is that you can see fundamental properties of our universe, right? Like how, like what light is and how light works for, like with a...
Yeah, you can't see any of it. Yeah, that's the whole problem. We can't see it. Okay, we can see effects, but we can't see how it's interacting. And you're pretending that because it has some little similarity with water waves in one circumstance that somehow that's the answer, when it doesn't match in the single slit and it doesn't match in the multiple slits. So how do you explain that?
Really cheap laser and a scalpel and some aluminium foil.
I mean, and how do you really explain a single photon interfering with itself? What you really think happens? You think a single little photon goes into a slit, a single slit, and magically breaks into a bunch of little pieces and interferes with itself, and somehow collects all its interferent pieces back that land in one location. The same little photons that travel all the way across space without having to do any of that horse shit.
Right, and like it's nowhere near as pretty as this, right? But you can still draw the same conclusions, right? And kind of the idea of the people.
You can draw conclusions, or you can say, you know, this is an interesting pattern, but there's a lot of circumstances here that we don't know anything about, and there is this weirdness about refraction anyway. We already know that light is reflected off of surfaces, that it bends, that it changes its path. And what are we doing different here? Well, instead of transitioning from one medium into another medium, we're pushing photons right through that transition zone. We're putting them in through sideways. So instead of putting them through this way, we're putting them through this way. Now we know when photons do that in Earth's atmosphere, a lot of stuff changes. It changes from blue sky to red sky, you know, because of that change. So, you know, why don't you do a little bit of careful thinking and realize that you don't have enough evidence to draw these conclusions, not even close to enough evidence.
Were experimenting with this for the first time. They didn't have lasers back then. Do they have lasers back then?
No.
Lasers were like 19...
So you can't even figure out they didn't have lasers back in 1801. Yeah, no, they didn't have lasers back then.
60s?
Yeah, they were just polymated light and then focused it.
So it wasn't culminated, well, culminated by the sun, yes. And they didn't focus it, they just put it through a small aperture. They bowed it.
And project it like a pinhole camera.
We could try doing that actually. Maybe next time.
Maybe next time.
But yeah, I think that's like to me that's one of like the wonderful things about physics is like you just get to play around. Like what you're experimenting on is everyday stuff, right? And the fact that you can do it with really really cheap equipment to find something so fundamental about light.
Yes, you don't find out something fundamental. You do an experiment, it gives you a piece of evidence, but it's a piece of pretty shabby evidence, and so, you know, deducing a crime based on, you know, without fingerprints or without DNA and without, you know, I don't know, plaster to put in shoe prints or something. You know, the more tools, the better. And these sophisticated tools are useless if you don't bother saying, well, let's do a single slit first and see what the pattern looks like.
That just kind of blows my mind.
I'm curious how this slit would actually go with our expensive laser here.
Well, let's do some science and find out.
And you don't want to use the aluminum to reflect the laser beam into someone's eye?
We'd rather not do that. Yeah.
I mean,
Yeah, put it in white side.
I can actually turn the key and turn it on.
More mechanical intensity would be great.
Right, let's just look at here.
So he's putting it right over the front of the laser beam. So he didn't do that with the other thing. He's just sticking it on the front of the laser beam. Not going to work that way.
Truth?
Moment of truth.
That's working.
It's hard to see interference.
I'm thinking that might be single.
It could be single.
A little bit.
Well, single.
Oh,
that's
for,
nice
for
single.
a second there was something else.
That's a beautiful single slit, actually.
I think the slit. The slits are just too far apart. The beam.
Nonsense.
Is actually
You can hold it a bit off.
so
Hold it a bit forward.
what we might need to do is actually
If you're getting the light, the beam's obviously not too big. You know, the single impediment can't be too big. They can't be too far apart if you're getting that much light on the target. Not possible.
It does that single split
bring
beautifully.
this back. We can diverge the beam slightly.
Flip through.
And put it through.
So we're just using the central maxima
Yeah.
from a good single split pattern to try and make a double split pattern.
So the beam diameter of this laser is too small.
So apparently they cut it out, you know. So his failures. But those are his failures, not the fact that he should have gotten a pattern. There's nothing different fundamentally between the lasers. They probably have a very similar size of the beam. Just nonsense.
To work with these slits.
Okay.
That's why we have professional.
That's why we have bad lasers with bad slits. Because these beams are huge and
So for our purpose, the laser pointer was actually better.
yes.
Yeah.
So again, just nonsense. Plenty of light was going through the slits, and yeah, and just your slits suck.
Just as we're considering what the final price points will be, we're thinking we probably need to include some of these rails and other things that actually enable us to use this laser. So Liam is looking up a quote for a rail.
What is this?
Definitely the wrong type of
50 centimeter.
So totally uninteresting. You know how much you spend. You can spend a lot. You can spend $20. You can spend $30 and do it really well. You can get a pretty powerful green laser for $10. So.
50 centimeter.
And we'll add this as a misc item on the quote.
Okay.
That's the wrong sort. Yeah, so we're not getting in 3D printers. Look, I'm saying
That's
it's
really what comes up.
It's priceless.
So this is just such a waste of time.
Because, you know, I'm not finding a story. It is old, I'll give it
What
that.
is the kind of a reasonable price that we can do it at?
Well, how much did our breadboards cost when we bought? They were about $300.
So, yeah, the precision cut very nice. These ones move and stuff, so yeah.
Yeah.
3 to... And it would come as a set as well, probably, so...
So $300.
So 300.
3 is pretty cool.
So the total for the cheap experiment works out to be 5 plus 5 plus 10 cents. So it works out to be $10.10.
Okay, I've got the talk. The total for the fancy one is 2,000 plus 200 plus 300. That's 2,500.
$200 for the double slit. Oh, please. Please. An insane price, anyway.
Coming in at a significantly higher
Right, and you did a lousy job with pretty expensive, tools.
price point. But did we really gain that much more value from this?
Yeah, I think this is
the
open
critics
for the
think?
discussion. Let's critics getting it.
Yeah.
You know, I think the $10 version definitely worked.
Yeah, I think we saw the same thing that we needed to see.
Right, so they didn't see any of the traditional double slit pattern at all.
You know,
Yeah.
it's probably
Well,
what.
imagine if you were discovering the effect for the first time. I think the cheap one would have definitely led us on to the fancy one.
Yeah, I think, why would we even need such a fancy one? Maybe demonstrating to a lot of people and we want something to be reliable. Maybe this is more reliable, but
But the fact
Yeah, neither pattern was very good, actually. Just rubbish.
that he can do this with, maybe a bunch of school kids.
Given enough space.
School kids, unlike you. You're a school kid. Newsflash.
You might actually be able to
Little wavy hair guy. It's one of those people who wants to have hair they have to play with all day.
take some good measurements with the cheap one.
yeah, and this is certainly do at home, so whilst we're not recommending the pencil at home, this one, have a shot.
But also be careful with your
Yes.
eyes and lasers and scalpels.
Alright, thank you for watching us play with some double slit experiments today. Hope you maybe learned something or got some inspiration to try yourself. Thanks to you guys for being in my video. I'll put some
Just another horrible video. She did this stupid Dr. Quantum video. She did a lame excuse of why she used that rubbish piece of crap religious nonsense. And now this. And now this piece of crap where she still can't get the facts right. Girly man physics.
links down in the description to some of their channels and other things that they work on. I'll see you next time.
Oh yeah, so I'll go find one of these other idiots who obviously don't know anything about the fundamental physics either.
Thank you.
I would like to thank Brilliant.org for sponsoring this video. Brilliant had a course.
Yes, and they sponsored it. They sponsored the creation of a piece of crap. You know, an absolute piece of crap. So go to Brilliant to get stupid, because obviously they don't know what the hell they're talking about either if they would sponsor a video that doesn't have anything to do with real physics. Just an absolute piece of propaganda crap. And she has some stupid bloopers here where they can't do their simple addition correctly. Ha 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 ha. So just horrible, horrible, awful, horrible, terrible, dismal. Just no wonder physics is such a mess. This is how they've been taught. Yeah, and you can see it. You know, because these big professional talking heads, they also have no clue. They also draw the single slit as, oh, it's just a blob of light. I mean, that's how bad it is. Bad.